Hey guys, in this video we're going to delve a little bit deeper into the periodic table and look specifically at how some of these elements behave and some of the clues that the periodic table can give us to help us with some of the work that you will see coming up a little bit later in the 6 weeks. So again, these are going to be your notes over the periodic table of elements, so let's jump right into it. So elements are arranged and identified based on the number of protons that they have in their nucleus. So one of the first things I need you to do is write down what the atomic number is. Your atomic number is equal to the number of protons in an element. You should already be familiar with that. You also need to remember that they can be equal to the number of electrons under some special circumstances. Okay, so remember that ape-man foldable that we made? Excuse me, sorry. Where the ape stand for atomic number equals protons equals neutrons. So that's what they're talking about here again. So the atomic number is equal to the number of protons, and they can also be equal to the number of electrons. And I'll teach you how they're equal to those electrons later on. So the next thing you need to write down is the atomic mass, what the atomic mass is. It's not the same as the mass number when we talked about isotopes, so this one's a little bit different. It's found on the periodic table. It's going to be the decimal number on the periodic table, normally below the symbol, but above the name of the element. And it is the mass in grams, so it's measured in grams, of 1 mole of an element. So it's how much 1 mole of an element weighs. Okay, so another way to think of it is atomic mass is kind of like atomic weight. So again, your atomic mass is the mass, so how much something weighs, in grams of 1 mole of an element. So how do atoms react? How do atoms of elements react? They react by doing one of two things, either gaining or losing some of their electrons. So an atom reacts by gaining or losing an electron. When we talk about a reaction taking place, what's really happening is some atoms are giving away some of their electrons and other atoms are taking electrons from someplace else, from another atom. Why do atoms react? They react because they're all trying to be stable. And the only way that an atom can be stable is if it has a full energy level. So if you look at this picture that I have here, this element, is sodium. It only has 1 electron in its energy level, its outer energy level. To be stable or full, it has to have 8 electrons. So this electron is going to be given away. It's going to go to chlorine. When it's given away, this energy level is no longer needed. And if you look at the next one in, look, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons. So now this element would be stable. This element over here is chlorine. It's not stable because it only has 7. Look, 1, 2, 3, 4, 5, 6, 7. When it receives that electron from sodium, it gets its 8, and now it's stable. So atoms react so that they can be stable. How do they get stable? By having a full energy level. What does that mean? 8 electrons. Must have 8 electrons to be considered a full energy level. So the last time we talked about metals and nonmetals. Now we're going to talk about how these two behave. Like, do they give away electrons or do they take electrons from someplace else? So starting with metals. What metals do is they donate or lose electrons. Okay, so metals donate or lose electrons. When they do that, they're called ions. So by giving away their electrons, it gives the metal, that giving away gives the metal a positive charge. So it makes it positive. Makes the whole atom positive. Positively charged ions are called cations. Positively charged ions are called cations. Okay, so metals donate or lose their electrons. It gives them a positive charge, and then they're called cations once they're positive. So the next thing says define oxidation. When elements lose electrons and increase their charge, that's oxidation. So oxidation is when elements lose electrons and increase their charge. They've become oxidized or they've undergone oxidation. So now let's talk about nonmetals. Nonmetals are going to do the opposite. So nonmetals gain or accept electrons. This gives them a negative charge. And negative charged ions are called anions. So nonmetals gain or accept electrons. It makes them negative in charge. It gives the atom an overall negative charge. And they're called anions when they do that. So when they become negative, they're called anions. Your next question says to define reduction. Reduction is when elements gain electrons and lower their charge. So it's the opposite of oxidation. So oxidation is all about losing electrons but increasing the charge. Reduction is about gaining electrons and lowering the charge. So because of how metals and nonmetals behave with electrons, they react with each other. So metals and nonmetals react with each other because metals lose electrons and nonmetals gain electrons. It's like they're literally exchanging. Here, you can have this electron because I don't want it anymore. And hey, I'll take that electron because I do want it. Okay, so there is a pattern to gaining and donating electrons, and we can see that on the periodic table. So you have a periodic table, I think, for this section, so go ahead and let's look at that and kind of figure out how this is going to work. So I want you to think of it as coming or counting from the outside to the inside. So if we start over on the left, our first group is going to donate 1 electron or lose 1 electron. Our second group is going to donate or lose 2 electrons. If we go over to the right, that first group on the very end of the right-hand side of the periodic table, the noble gases, they don't gain or lose electrons because they're already stable, so they don't have to react at all. The next group in, group 17, they're going to gain 1 electron. Group 16 will gain 2 electrons, and then it changes as we get closer to the middle. But for right now, that's the 4 I want you to remember, or the 5 I want you to remember. So again, group 1, they donate 1 electron. Group 2 will donate 2 electrons. Group 17 does not donate or lose electrons. Sorry, group 18 does not gain or lose electrons. Group 17 will gain 1 electron, and group 16 will gain 2 electrons. Okay, so the periodic table can also be used to determine the charge of our representative ions or elements. Remember, our representatives are the ones here and over here. Okay, so these guys and these guys, those are representative. So I'm going to write this in. I want you to write yours in on your periodic table. So here we're talking about charges, either pluses or minuses. So let's start over here on this side. Group 1 is going to have an overall charge of +1 because all of these elements have 1 electron they can give away. Group 2 will be +2 because all of these atoms have 2 electrons they can give away. Group 3 +3. Now group 4 is special. They can choose. They can either give their 4 away or they can get 4 from someplace else. So they can be plus or minus 4. It just depends on what they want to do. They can do both. Now from here on out, we're going to start being negative. So we know that these guys in group 18, they don't give or lose electrons at all, so they don't really have a charge. They're what we call neutral. Group 17 are -1 because they're trying to say, hey, I need 1 electron. I am missing just 1 so I can be stable. Group 16 is -2. Again, they're saying, I only need 2 electrons to be stable. Group 15 is -3. So it kind of goes in a pattern. On this side, as we go in, we get more positive. On this side, as we go in, we get more negative. So think of the plus as this atom's way of saying, I have this many electrons to give away. Here, take them. Think of the minus sign as saying, I need these many electrons. Please give some to me. So that's kind of what's taking place. All right, so you should have these numbers copied down on your version of the periodic table on your notes. Okay, so now you have to use your periodic table to predict the charges of the following ions. And it's just based on those numbers that we've written in. If they're in a group with a +1, it means every single element in that group will be +1. If they're in a group with a -2, it means every single element will be -2. If they're in group 18, it'll be 0 because they have no charge whatsoever. So sodium's in group 1, they're +1. Oxygen, excuse me, is in group 16, so they're -2. Sulfur is also in group 16, so they're -2. Beryllium is in group 2, so they're +2. Chlorine is in group 17, so they're -1. Potassium, what am I saying? Phosphorus, sorry, is in group 15, so they're -3. Potassium is in group 1, so they're +1. Iodine is in group 17, so they're -1. Calcium is in group 2, so they're +2. Fluorine is in group 17, so it's -1. Magnesium is in group 2, so it's +2. And the last one, argon, is in group 18, the noble gases, so it is 0. It's neutral. No charge. So go ahead and fill your sheet in if you haven't already done that. Okay, the transition metals are the D block metals. We talked about that before. Those are the little ones that are kind of in the middle. They're shorter than everything else on the top part of the periodic table. So because of this, the number of electrons they lose is not as easy to figure out. They're not as predictable. So the charge of a transition metal is shown by the Roman numeral that we use in its name. So like iron 3, for example, is going to have a +3 charge. Iron 2 is going to have a +2 charge. Copper 1 is going to have a +1 charge. Copper 2 is going to have a +2 charge. So it's just based on whatever Roman numerals we use. So for this part, I just want you to look at what's given to you and try to figure out, based on the Roman numerals, what the charge on these transition elements are going to be, or these transition metals. So the first one is palladium 2. So 2 suggests that its charge is going to be 2. The answer for this one would be +2. Then there's vanadium 4. So this is going to be +4. Lead 4, also +4. Platinum 2, +2. Cobalt 3, +3. Manganese 3, also +3. You should be seeing a pattern. We've done 8 elements so far. Actually, it's more like 10 elements that we've done, and they've all been plus whatever their Roman numeral is. So hopefully you're realizing that transition metals are always positive. All right, so you should have these written down. Go ahead and write them down if you haven't already done that. Okay, so why is the charge of a transition metal always positive? Remember, metals always, metals always lose or donate electrons. This gives them a positive charge. So why is the charge on a transition metal always positive? It's because metals always lose electrons, and that makes them positive. Losing electrons makes them positive. Since all the transition elements are metals, they will all be positive. They'll all be cations. Okay. So there are a couple of different compounds that can be formed, but we're going to talk about 2. The first one's called an ionic compound, and the second one's called a covalent compound. Ionic compounds are always formed between a metal and a nonmetal. So who forms ionic compounds? Metals and nonmetals. Metals on the left, nonmetals on the right. They always get together to make ionic compounds. Covalent compounds, on the other hand, are always formed between nonmetals. So anything on the right, 2 of anything on the right, or 3 of anything on the right, however many, they can form covalent compounds. So let's recap. Ionic compounds only form between a metal and a nonmetal. Covalent compounds are formed between nonmetals only. So now that we've talked about all of this, let's do some practice problems. This first one is not going to be on your sheet. So we're thinking of ionic and covalent compounds. We're trying to figure out which is which. So this says NaX. So obviously X is what we're looking for. We don't know what X is. It says the formula above shows the ratio of an unidentified element X to sodium, an ionic salt. So that's our keyword. In which group on the periodic table does element X most likely belong to? So we know that an ionic compound happens between a metal and a nonmetal. Sodium is way over, excuse me, on the left-hand side of the periodic table, so sodium is a metal. If this is an ionic compound, it means that X needs to be a non-metal. So now let's look at our periodic table. Group 1 and Group 2 are both metals. Okay, Group 17 and Group 18 are nonmetals, but Group 18 doesn't react. So if they don't react, they're not going to form any kind of compound, so that one's out. These two are automatically out because they're not even nonmetals. This one's out because it doesn't react with anything, so the answer would be Group 17. Okay, this next one says, the formula above shows the ratio of an unidentified element, X, to fluorine in an ionic salt. Which group below is most likely the identity of element X? So again, we're looking at Again, we're looking at ionic. So ionic means metal and nonmetal. So fluorine, if you look at your periodic table, you'd realize it's on the right, which makes it a nonmetal. X is going to have to be a metal for this to be ionic. So what could X be? Look at your options and tell me what the best answer is. All right, I'm going to move the slide back up now. Now I know it says group, but it gives you actual elements here. So now you had to use your periodic table to figure out which one would be the most likely answer. And lithium is a metal, and it's found over on the left-hand side of the periodic table, so lithium would be the right answer for this one. All right, so this is the last one. So it says the formula above shows the ratio of an unidentified element X to chlorine in a covalent molecule. Which element below is most likely the identity of element X? So covalent, Covalent means non-metal plus another non-metal. Chlorine is a non-metal because it's on the right, which means that X needs to be found on the right as well. It also needs to be a non-metal. So look at your options and tell me, which one's the best choice. Try to circle or highlight or whatever, the best choice. Okay, so now let's see what our options are. Oops, sorry, the iPad fell. So we're looking for which element could be part of this this compound, and we know it has to be a nonmetal because in the question they tell us that we're working with something that is covalent. So sodium's a metal, that one's out. Neon is a nonmetal, so maybe that one's a possibility. Copper is also a nonmetal, so that one's out. Now neon is in group 18, which means that it doesn't react, so that one's out too. That leaves us with phosphorus as our correct answer. Okay, so hopefully this wasn't too bad and was fairly easy to understand. I will keep talking in class about what we're going to do for the rest of the time. Bye, guys.